Good afternoon, everybody. My name is Eddy de Boer. I'm working at ProRail. ProRail is the Dutch infrastructure manager for the rail infrastructure. And I'm going to present together with Machiel van der Bijl the efforts we undertake to get a better quality software and also to control the software development together with our partner Axini. And we call the tool Model Based Testing, MBT. First to get some content. What is this talk about? First about the introduction of ProRail and ERTMS, because we do this case in the big surrounding of the program ERTMS, and then we switch over to why Axini MBT and what is Axini MBT. There will Machiel van der Bijl will take over. Part of the conclusion he will also tell us, and I will take over the last sheet again. The ERTMS program is a very big European program where the Dutch government is also taking care of and taking a huge amount of effort in order to have a better railway system in Europe. And the main reason is to get goods and freight easier throughout Europe, but also to have more passengers in the trains and have a good competition with the airplane. It is a very big effort in order to harmonize the way of working of the infrastructure managers and the railway undertakings in order to use the railway tracks much better than today. In essence, it is a replacement of our current safety systems. And the word safety says enough. It needs to be safe. And all the rest is all politics and all why we do this stuff. In the Netherlands, we will first take care of a number of corridors, but ultimately it is the goal to put the whole of the Netherlands under ERTMS train safety systems. Okay, what do we need to do then? The most important thing we need to do is that we have to directly connect our IT systems where we do our control, our traffic control, to the train, the actual train driving on the tracks. That's not what we do today. The cabin driver has the ultimate control of the train, as put down on the left of this picture. And on the right of this picture, you see where ERTMS comes into place. Then we also talk to the train directly via a system called RBC. The new software we need to make is the ETIS system. ETIS is a piece of software where the traffic control software is connected to our safety system, using to control the train and to control the train operation. That's new, and it is a safe environment. It needs to be safe what is done there. Otherwise, we end up with some possible collisions or other stuff, and we do not want that. In our reference architecture we use, the ISA 95, there it is in level 2. And level 2 means directly connected to production. And directly connected to production also means that there are a huge amount of non-functional requirements involved, a huge amount of safety regulations involved we all need to comply to. And that also means that we need to have very robust software from day one. We are not focusing on an agile production. We are focusing on agile development. We are focusing on agile operations, but we are focusing on a robust operation outside. That's the surrounding of where we use model-based testing. So I now give over the floor to Machiel to give us some more information about what is ETIS and what is Axini doing with their MBT in that development. Machiel, the floor is yours.
Yeah, okay. Thank you very much, Eddy. About the introduction where we use our tool set. I'm Machiel van der Bijl, CEO and co-founder of Axini. And I will talk you through the tool set that we use. We call it these days no-code test automation, which is a form of model-based testing. And first I will tell you what it is compared to other tools. and after that how it fits in the process at ProRail, and how we achieve a higher quality and more and give ProRail more control. So if you look at the test approach, if you look at the steps, the manual test steps, you need a specification, you create a test case, you predict the outcome, you execute the test case, and you check the outcome. Those are the normal steps that you do while testing. And if you do them all manually, of course you do them all manually. If you look at the standard in test automation, that's scripting. And with scripting, you get a new step with it to script the test, to program it, so to speak. And because you program it and you use the steps of the test case and the predicted outcome, you can automate the test execution and the checking of the outcome. And then what is the way that Axini uses? That is a way where you model the system. So very similar to the talks that we saw before, but in our case we use the model for the testing part. And what's unique is that you can do test automation where you don't have to program the test scripts. And this gives several benefits. One is it's the most thorough way of testing that's possible, and it's a maintainable way. Because quite often when you have the test scripting, you run into problems where you see that, oh, that was too fast, where you see that the maintenance of the test scripts becomes bigger than the maintenance of the system. So this is why, with the approach, why we help ProRail with testing more thorough and also to test faster. Well, if you look at ETIS, the way Eddy already introduced it, it's a complex system in the sense it's a communicating system over 3 interfaces, so you can get 6 input-output combinations concurrently working. And if you then look at the way the software development process is, if you look at it backwards, so if you start with production, in production, actually, in general, in production, that's the best environment to test. But of course, you can't do that as ProRail. It's some company like Facebook, they test in production, and if you can, you have the setup to test. But for ProRail, that's not possible. So the next best thing is to do the acceptance test. But also there, you actually don't want to find bugs. Because look at ETIS, you have an acceptance test roughly 4 times in a year. So if you encounter problems there, you don't want to have that, because then it will take another quarter. Then you have development. And during development, you actually don't have that much help in testing the system. You have the system itself, but not its environment. And when you look at design, the design level, you only have the idea. You have the documentation. But there's a counterintuitiveness to this, because in production, you can test the best, but you don't want to have errors there, because they're the most costly. And the next best thing is acceptance test, but like I explained, you don't want to have that there as well. During development, it's already better, because you can fix it relatively easy, and the best place to find bugs is during the design. So the power of testing is highest on the right-hand side, and the cost is lowest on the left-hand side. So how can you, with a technique, with model-based testing, the Axini Model Based Testing technique, how can you achieve that you, what's now called shift left, that you find bugs earlier? So you want to prevent problems, you want to find problems as quickly as possible. If you look at the setup, on the left-hand side you have the model, on the right-hand side you have ETIS, the implementation, and around ETIS we have an adapter to communicate with ETIS. And in the middle you see the Axini tool set, and it uses AI, machine reasoning, to follow all the paths in the model and to derive test cases from the model. It tries to cover all the paths in the model, all the possible interactions over these 6 points of control and interface, and executes them against ETIS. And what you then get is the following picture. In production, everything still stays the same. It's still, let's see. Yeah. And during acceptance tests, you also have the same situation. But during development, you can test just as powerful as in during the acceptance test. And actually, a similar thing happens during the design. So there you have the ETIS model, and with our tool set, the Axini modeling suite, you can already interact with the design. And that way, you can find more bugs during the design and also during the development, which prevents bugs to be, that are found during the acceptance test. So those are the two main parts why with this approach you get a higher quality and you get more control, so you have less surprises, you find problems earlier. Now, how does this work in practice? How does this modeling work? And you've seen already a couple of examples. And on the one hand, there's interface modeling, but for testing, you also need system modeling. You need to predict what the behavior of the system is. So what you see is the models that you need for model-based testing are a lot bigger than other models. And we start from the outside in. So we start, like we've seen this morning, we start with what are the interfaces. So if you have the system, what are the interfaces? Or in our case, we call the interfaces channels, the points over which you communicate with the environment. And for this, I just gave an example here from a door interface, and you want to open it. So you have inputs, stimuli, outputs, responses. You can have data on them. There are timing constraints. But this is only the start of the modeling. So now you know what you are allowed to send and receive as a system. But you also need behavior. And for the behavior, you need to tell what inputs and outputs, are the relation between inputs and outputs over these, for ETIS, these 6 interfaces. And for the behavior, there are a couple of things that are important. You have timing, you have data, and data is important. And we have under the hood, there are things like constraint solvers to come up with clever data during testing to cover all these possible interactions that the system can do. But if you look at bigger systems like ETIS, the real interesting stuff happens in the concurrent behavior. So it's a system that has parallelism involved, and that's also where you see if you do that up front. So if you start the modeling at the beginning, you immediately have a good discussion. So you have a discussion, yeah, but what happens if on this interface this happens and on that interface that? What should be the result? And quite often, if you don't have tools to support with that, it's written down in a Word document, and you introduce under specification. And with modeling, you make that explicit and you are forced to deal with it up front. And just to give an impression of the ETIS model, so this is the visualization of the model. I've taken 3 components. So these are 3 parallel components. You see submodels, so we can split up models to keep them maintainable. So let's see, to come to the conclusion, if you look at what happens when you model these kind of big systems is that you can find errors earlier on. And that is because of the modeling, we can test more thoroughly than with other approaches. And we can also start earlier with the testing, the validation, the verification. And so it's earlier and more. And because you fit it in the process, what you see is that you also find errors in places where you normally don't find errors. And of course, that's also what you see with for example, with comma. If you already start at the design phase, you prevent a lot of problems. And then I hand over for the final words to Eddy to conclude.
Yeah, for example, with comma, if you already start at the design phase, you prevent a lot of problems. And then I hand over for the final words to Eddy. For example, with comma, if you already start at the design phase.
Okay, so the conclusion coming from ProRail in this respect is, of course, what do we do with it? And what we do with it is that we have a better proven approach for quality, and software quality is higher. And that means that immediately we end up and what we just have seen is that we can find bugs much earlier. And that means that earlier in the design process, we can do bug finding and preventing bugs of coming along. That also means that you need a different control in terms of projects, because in most of the projects, system integrators and testing people are used to getting a lot of first early deliveries for software with lots of bugs in it, and they don't see anything anymore. Also, project leaders, they think that software is better all the way, and why is MBT then so good? So selling the whole concept is still a big thing to do. In the end, coming from an architectural perspective, I'm an architect. I see that the total cost of ownership of a piece of software, of a system, is going down and is lowering, and that's the main reason why we do this. It's also said that we do it already since 2012. I joined ProRail in 2008, and at that time there were the first discussions with Axini about this whole idea of model-based testing. From 2012 on, we have done several projects using this stuff, and I must say I'm enthusiastic about it. It helps us to get the quality and the integrity that we need in order to deliver the Society of the Netherlands a good and healthy software product. And as Machiel pointed out with the bugs on the sheets, you see a complete shift left. And that means also that the designers are now more in the area where there's big discussions are, and not the testers anymore. And that helps us. So in the end, concluding, we are, as ProRail, enthusiastic about using MBT in order to get the software quality in first instance already better than we anticipated earlier on. Thank you for your attention, and happy to answer any questions.
Well, let's take some questions here. I have a question for Machiel. Machiel, how does Axini interact with ETIS? Assume the adapter contains handwritten code, or is that also generated?
No, indeed, it's a combination. It is a standardized protocol, and of course, the communication with our platform is standardized. That's protobuf over WebSockets. And the communication with the system is, of course, it depends on the system. So in this case, it's, for example, XML over web services on the top end, so with the process lighting. On the bottom end, it's more a dedicated protocol over SCTP. And on the left-hand side to Asterisk, that's also XML over web services. I don't know if that answers the question. So there's a combination, there's handwritten, which I was inspired this morning I was thinking about it, well, might be interesting to see if we can make a DSL out of it. We have some sort of a DSL, but I think it can go further than what we have now.
Okay, here's one from Brian Bakker, Siux. Machiel, what kind of skills are needed to define models for testing compared to skills of test engineers and designers?
Ooh, that's a good one. They're different. But I think the most important thing is that they're domain specialists, so that they really know the domain. What we see, what is really difficult it's a change in mindset. So instead of thinking about a test case that you want to have, you now have a tool that comes up with the test cases. And of course, you can check afterwards if a test case hits a certain property, that the properties that you want to test are also hit. So the skill set is more towards design than to test. So in the end, it's the tool that should do the testing. That's automating the testing. And it's the model that drives the testing. So it's more modeling, less testing.
Okay, here's one about possible collaboration from Ronald Bos. I'm wondering, says Ronald, let's say you want to model-based test a system that has been designed using COMA. So we already have a model of the system. For testing, we then need a new model. Not sure if I'm right, but it would be nice if this could be integrated.
True. So you always have the thing with testing validation. If you use a model to derive your system, so to generate your system, then how do you know if your system is correct? If you would use the same model, then you're basically only testing the test tool set or the code generator. So you need two things orthogonal to each other. And we also have clients that do that they have a specification model and a test model, or a specification model and an implementation model. I don't know if that answers the question, but it's indeed in this case I would say if there's I think for testing in general you have richer models, bigger models, but I'm not entirely sure. But what I've seen from COMA so far, it's really towards the monitoring during the runtime. So there are already test cases, or there is a production environment, and you now check whether it adheres to certain properties on the interface. And with no-code test automation, the Axini form of model-based testing, there you generate the test cases. So I would assume that you need to have more information in the model than what is available in the COMA model. But yeah, I think it's a good idea to figure that out together.
Okay, we have a stream of questions coming up. I'll look at Nike to have a timeout, but we have 4 more here. Machiel, again, how big is the behavior model created for testing compared to the actual implementation? To give you a feel, there are, from the top of my head, 4 people involved in the coding. So the implementation of the system, and there's 1 model-based test architect. So it's a 1 to 4. But these models there are really big. I mean, the state space. So what you see with these with reactive systems on this scale, with 6 parallel interfaces,
You even get state space explosion during online test execution. So we really have to make sure that we contain the state space, that we really cover all the interactions. But of course, we also abstract from certain things so for example, ETIS has a big translation from the way how the track layout is on the system below, the RBC system, and the track layout that process lining uses. For the MBT, we abstract from that part. So we are really focusing on the interfaces.
Okay, thank you very much, Ivo ter Horst, for asking that question. We have now one question from Micah Mustard. Using the same model, can you also implement the model? Using the same model, can you also implement the model? Abstract question.
I'm not. I don't exactly. Maybe the person can give some more information there.
Yeah.
I think the way I interpret it, but please type if I'm wrong, is can you use the same model for testing and for code generation? Technically you can, but the question is, what do you test? Because I wouldn't do it in practice, because you're just testing whether either the code generator works or the test tool works. And you really need, I think if you look ahead, what we want in the future is that you have one model, but besides the model, properties that the model, requirements that the model should adhere to, that they can then check with in several ways, either, for example, with model checking, with model-based testing. Maybe you can prove properties of your code generator. So there are more techniques that you can use than only either modeling or model-based testing or domain-specific languages. There's a lot more that I hope will come in the coming years.
Okay, here's one from Ronald Bos. How does AI fit into the equation? What inputs, outputs is it trained on?
It's the AI that we use is a machine reasoning AI, so it's not a machine learning AI. So that's important, an important difference. So the AI analyzes the model, analyzes the state space, and based on a certain test strategy, it tries to optimize the coverage. For example, one test strategy is to hit every state. One test strategy is to hit every transition. You can do path coverage. You can do path coverage and data coverage. What's interesting is we're also looking into model AI systems. And then you get interesting questions like what is correctness? What does correctness mean for an AI-based system? For example, if you have a Tesla, when is it correct? When is the autopilot correct? It's difficult to prove.
Okay. Here we have a connected question to the former question about the model of the model, implement the model. Mike Mustard, maybe the question is already answered. The last one, connected to the model.
So the ETIS itself in this case. I think so.
Maybe you can repeat it or say it's
okay.
Yeah. No, dan ga ik afsluiten.
No, there's
one more. Not on my stream.
Yeah, and there were also people that asked, could you give more details about the tool? Well, we deliberately chose not to go into too much detail and do a demo, given that we also already had multiple speakers. And then either your demo suffers or your presentation suffers. So we really wanted to focus on why does it help ProRail. But of course, if you want to know more, please contact any one of us three, and we can give either a demo or whatever. One more?
Yes, we have one more. Brian Bakker of CUX. When abstracting from the behavior, differism cannot.
Non-determinism.
Oh,
yeah.
Might be introduced.
Definitely.
Can Axini tooling handle this?
Well, if you want to do model-based testing, you have to have you need to support non-determinism, and you can already see you have basically 3 interfaces with 6, where on 6 points of control and observation you can interact with the system. So you have non-determinism. If the system, it can give an error, or suppose the top level is not connected and you communicate at the bottom, you either, and you don't know that, then you can already get 2 answers. You can get an error, or if it is connected, it just gives a normal reply. So you need, with model-based testing, non-determinism is a must. And the difference in the models is also that, for example, the models that are used for model-driven engineering are almost always deterministic, whereas the models for testing they accept a set of implementations. So there is non-determinism involved.
Okay, then I'd like to conclude with a message from Jozef Hohmann. He says, that's from COMA, of course, think it should be possible to generate a model that can serve as input for Axini tooling.
Or the other way around.
Yes.
Just kidding. No, but I think it's really interesting to see. We already looked at it. How does COMA and our tool set, how do they relate? There are a lot of similar concepts, and I think for the industry, it's really helpful if there is a standard model on which you can work. So I think that's really good.
So thank you for all the questions.